All right, guys, so here we go. Lesson 1.6. We're looking at other types of equations. Now, for these other type of equations, I'm going to break them down into different parts. So we're starting off with number one, which are the polynomial equations. Now, when we talk about the polynomial equations, guys, we've already seen them. Those are the quadratics, the linear equations, all of those belong on the polynomial equations. So what's the difference between those equations and these that we're discussing tonight? Well, these are the higher degree polynomials. Higher degree polynomials. And in the case of higher degree polynomials, we're looking at degree 3 or more. And so for these type of problems, very similar to the quadratics, guys, I'm going to give you some steps to solve them. Now, number one is to set the polynomial equal to 0. Number two, you want to factor the polynomial. At this level, all the polynomials you're going to encounter are factorable. So you don't have to worry about what method to use. Just go ahead and factor them. Set it equal to 0 and just factor, guys. All of them are factorable at this level. So next, I am going to go ahead and clear this out. Okay, so step 3, we're going to set each factor equal to 0 and solve. Oops, I forgot my L. Okay, set each factor equal to 0 and go ahead and solve the problem. Now, guys, here's something you need to keep in mind as you're solving these polynomials. You will see this again. The degree of a polynomial, the degree indicates, it informs you as to the max number of solutions. It indicates the max number of solutions. So if you've got a 4th degree polynomial, then you're looking at potentially a maximum of 4 solutions. Now remember, guys, solutions, roots, or zeros, they mean the exact same thing. So if they ask you to find the zeros, the roots, the solutions, they all mean the same thing. X-intercepts, yes, those mean the same thing as well. All right. So now, guys, let me go ahead and start with some examples. Keep in mind, I will be mentioning which questions you're going to see on the test. So just make sure you pay careful attention. Number one is 4x to the 4th is equal to 12x squared. So in order to solve this problem, guys, the first step is to set the polynomial equal out to 0 by taking the 12x squared and moving it to the right, to the left, sorry about that. So we get 4x to the 4th minus 12x squared is equal to 0. Now, once you have your polynomial equal out to 0, the next step is to go ahead and factor the polynomial. If you look carefully at this 4th degree polynomial, it has a GCF of 4x squared, guys, 4x squared. Factor it out. Once you factor it out, you'll be left with x squared minus 3. And so you've got your factors. Now it's time to go ahead and take each factor, set it equal to 0, and solve. I'm erasing the top, guys, so I can have additional space to finish out the problem. So I am going to set the 4x squared equals to 0 and solve it. This is simply asking 4 times what number gives me 0? That'll be 0. You don't want to do all that work. It's not really worth it. Next, you're going to take the x squared minus 3 factor, set it equal to 0. You're going to add 3 to both sides. So you get x squared is equal to 3. Take the square root of both sides. So you get x is equal to plus or minus radical 3. So this 4th degree polynomial produced 3 solutions. And the 3 solutions are the 0 and then the compound solution in the form of plus or minus square root of 3. Now, guys, it is critical you work on the assignments and preparation for the test. So if you haven't started on the assignments, you do need to get started. If you haven't been on My Math Lab, you also need to get started on that. Let me know if you need help logging on. You just go to Blackboard, click on the My Math Lab link. It'll take you through the process. So guys, that's the first example. Remember, if you have questions, ask me questions, drop the questions in the chat. I'll be more than happy to answer your questions. Now, number 2, guys, is definitely on the test. So pay careful attention to this one. 2x cubed plus 3x squared is equal to 8x plus 12. This is a third degree polynomial. How do I know if it's a third degree polynomial? The highest power in this case, okay? So the first step is to go ahead and get the polynomial to equal out to 0. Isolate the polynomial. So I'm going to take that 8x, move it over to the left side. When you move a term from one side to the other side, it changes the sign as in positive, negative. It changes, guys. Next, move the 12 over to the left side, so it becomes a negative 12. Now, what you will notice is that you have a 4-term polynomial. Remember, I mentioned earlier, these polynomials are factorable, so you can factor this by grouping. So whenever you have 4 or more terms, guys, you have to factor it by grouping. Factor it by grouping. So I'm going to group the first 2. Notice I'm just putting parentheses around the first 2 terms. Group the last 2, parentheses around the last 2 terms. Find the GCF in the first group. What do these 2 terms have in common in the first group? X squared. So I factored out, leaving me with x plus, I'm leaving out the 2. All right, so that leaves me with 2x plus 3, guys. Next, I'm going to move on to the second group. What do these 2 terms have in common? They have a negative 4 in common. If I take negative 8x and I divide it by the negative 4, guys, I'm left with a positive 2x. And if I take the negative 12 and I divide it by the negative 4, that's going to leave me with a positive 3. It is critical, guys, when you are factoring by grouping, that these 2 parentheses are identical. If they're not, something's wrong, or the problem just cannot be factored by grouping. So now the parentheses becomes a GCF, so you want to factor it out. So this will leave you with x squared minus 4. Now the x squared minus 4 is a difference of squares, so you want to factor that further into 2 binomials, x minus 2, x plus 2. I'm pausing here just in case you have a question. If you have a question, guys, drop it in the chat. Any questions? I'm not done, by the way. Any questions? Remember, guys, this is being recorded. The video will be available later on. I will send you the link. I will drop it in the virtual lessons folder in Blackboard. So no questions? All right, guys, I'm going to keep going. Remember, this one right here is on the test. I'm going to erase this and continue with the problem. So the factors for the problem are 2x plus 3 times x minus 2 times x plus 2, and all of this is equal to 0. Now, guys, we need to find the values that would make the parentheses equal out to 0. What would make those factors equal out to 0? What x value minus 2 will make this parentheses equal out to 0? That would be a positive 2. And notice I'm not starting with the first one because the first one is a little complicated. So I'm starting with the second one because it's easier. And then for this one right here, what number plus 2 makes this parentheses 0? Negative 2. Now, since the first one is a little bit more complicated, I would actually suggest you set it equal to 0 and just go about solving it. Some of you are probably capable of eyeballing this and coming up with the answer, but for those of you who can't, just go ahead and work it out on the side, guys. So here's the resulting solution for that one factor. So guys, this one ends up with 3 solutions, which are negative 3 over 2, positive 2, negative 2. Notice, guys, when we started, I told you this was a third degree polynomial. And this one actually produced 3 solutions. So remember, the degree is an indication of the max number of solutions a polynomial can produce. So, any questions? Now, if you don't feel like asking your questions now, that's fine. You can ask them later on once I'm done with the recording, guys. Okay? Remember, this is on the test, guys. So a question you should be asking yourself is, if I see this one on the test, am I going to be able to do it? Will I be able to manipulate this problem and come up with the correct answers? Okay? So guys, here's the next one. The next one, number 3, this is also on the test. It's x to the 4th plus 5x squared minus 6 equals to 0. And let me also clarify this. When I say the problem is on the test, I mean one similar to it. I don't mean the exact same thing. Does it matter which order we put the solutions in? No, it doesn't matter, Larissa. All right, guys. So once again, you will find one similar to this on the test. So guys, it is already set equal to 0. So the next step is to go ahead and factor it. We want to find 2 factors of -6 whose sum is +5. 2 numbers that multiply to give you a -6 and add to give you a +5. That would be x squared plus 6, x squared minus 1. Those are your 2 factors. Obviously, the x squared minus 1 needs to be factored further because it's a difference of squares. So I'm just going to go ahead and factor that into 2 binomials, x minus 1, x plus 1. Notice, guys, I didn't factor the first one because it's not a difference of squares. So you leave it like that. So x minus 1 will produce a solution of 1. X plus 1 will produce a solution of -1. Now, the x squared plus 6, though, you actually need to set this equal to 0 and solve. So we're going to subtract 6 from both sides, and we get x squared is equal to a -6. Then you want to take the square root of both sides. Now, guys, whenever you take the square root of both sides, you will get a compound solution. That's part of what I discussed with the other class on lesson 1.5, which I sent you the link to. So make sure you watch that video. Whenever you take the square root of both sides, guys, you always end up with a compound solution, a positive or a negative value. Furthermore, there's a negative inside the radical, under the radical. Those negatives you encounter under the root, guys, become imaginary units. So the negative on the square root becomes an I, and then the 6 remains under the root. So essentially, this problem is producing a total of 4 solutions. You got 2 real solutions, 1 -1, and then 2 imaginary solutions in the form of plus or minus I radical 6. And that's it, guys, for this problem. And yes, this one is also going to be on the test. Let me also say this to you guys. When you are typing in the solutions to these problems into my math lab already has the plus or minus tool on the tools bar. So you don't have to break up the plus or minus I radical 6. You can just use the plus or minus tool. You can do the same thing with the +1, -1 as well. All right, guys. So that's the first section. Now, moving on to the second section. And remember, guys, drop your questions in the chat box. Part 2. This is where we're looking at the radical equations. And yes, you will see radical equations on the test. I believe there's 1 radical equation on the test, okay? When we talk about these radical equations, we're looking at any equation containing a variable inside or under a root. So some examples of radical equations might include something like this. Square root of x plus 2 equals to 3. Or perhaps the cube root of x minus 1 equals to 4. Both of these are considered to be radical equations. And we'll see some more later on, guys. Now, on this one right here, to solve these radical equations, the first step is to isolate the radical. get the radical by itself. Now, once you have the radical isolated, your next step is to eliminate the radical. We're going to eliminate the radical. In order to do this, guys, you must raise it to its inverse. You're going to raise it to its inverse. So I'm going to show you guys what I'm talking about in a minute, okay? So eliminate the radical by raising it to its inverse. So here we go. Right here, guys, I'm going to use a different color. You had square root of x plus 2 equals to 3. We want to get rid of the square root. So to get rid of it, we're going to do its inverse and square both sides. By doing this, the square cancels out the root, leaving you with x plus 2, and then 3 squared gives you 9. Now, the other one is a cube root, so its inverse would be the cube, or raise it to the third power. So you would go ahead and raise both sides to the third power. So the power would cancel out the root, leaving you with x minus 1 equals to 64. That's what I mean by raising it to its inverse. And of course, once you get rid of that radical, you have a simpler problem to work with. And so the next step is to go ahead and solve, guys. You're going to solve the equation. So step number 3 is to solve the equation. Now, when you're solving these equations, guys, be very careful. Why? You must go to step number 4, okay? There's no ifs and buts about it. Go to step number 4, especially if you end up with 2 solutions. You must check the solutions, because sometimes you find these solutions which, when you plug them back into the original problem, they don't make the original problem true. So you cannot count them as a solution. So these type of solutions, we refer to them as extraneous solutions. I mentioned these to you guys before, extraneous solutions. These are solutions you'll find which doesn't make the original problem true. If it doesn't make the original problem true, then you cannot count it as a solution. You must throw it out. Okay, guys, I am going to go ahead and do 2 examples here. And remember, you are going to see this equation right here on the test. All right, so here's the first one. Now, this one right here is very simple, guys. And this is actually an exception to the rule, okay? Now, let me put a star next to it. This is an exception right here, guys. And the reason why I'm saying it's an exception is because you've got a square root equal to a negative value. So the question you need to ask yourself is, can a square root, can you take the square root of a number and end up with a negative value? That would be impossible, guys. So these type of questions, if you can notice that, and you can go ahead and logically figure it out, you don't even have to solve it. You just say there's no solution, because you cannot take the square root of some number and get a negative value. Now, if for some reason you were to try and solve this problem, this is what you would do. You would square both sides. So you get x plus 1 is equal to 36. Subtract 1 from both sides, and that would give you x equals to 35. Now, guys, this is why there is a case for checking our solutions. So if we were to check the solution on this one, look at what would happen. If we take the 35, we go back into the original problem and we plug it back in, look at what would happen. If we take the 35, we plug it in for x. 35 plus 1 would give us 36. Square root of 36 is actually 6, not negative 6. So since 6 cannot equal to negative 6, it means that the answer you found, the solution you found, is not making the problem true. So there's no way you can keep it as a solution. So it becomes an extraneous solution. And since it was the only solution and it did not make the problem true, you must throw it out. Okay, discard it, reject it, guys, and say there's no solution. So be careful with these. All right, so now I'm going to do the problem that is actually on the test. And guys, here it is. And you will see questions like this on the assignments too. So here we are. This is number 2. It is square root of x plus 3. Oh, shoot. I have another plus 3 is equal to x. That's not a really good question here. Okay, guys, first step, isolate the radical. Get the radical by itself. So we're going to take the positive 3, move it over to the right. So we get the square root of x plus 3 is equal to x minus 3. So now the radical has been isolated. So now we can go ahead and get rid of the radical by squaring both sides. So we square both sides. So we get x plus 3 is equal to, now guys, here's where you need to be super careful. You have an x minus 3 squared. X minus 3 squared means x minus 3 times x minus 3. So you're going to have to FOIL to solve this. So x times x is x squared. Then you're going to do x times negative 3 times x. So that's going to give you negative 3x minus another 3x. So that's going to give you a negative 6x. And then negative 3 times negative 3 is positive 9. So I just FOILed the x minus 3 times x minus 3. Now, next, it's a quadratic, guys. It's a quadratic. So I need to set the quadratic equal to 0. So I'm going to subtract x on both sides. Subtract the 3 from both sides. So I'm doing 2 steps here, guys. I'm subtracting x on both sides. I'm subtracting the 3 from both sides. What is my goal here? My goal is to make the equation equal out to 0. Set the quadratic equal to 0. So guys, now it's equal to 0. And then I am going to factor the quadratic. I got to find 2 numbers that multiply to give me 6. Add to give me a negative 7. That would be x minus 6. X minus 1. So now that I have my factors, I can ask the question, what number minus 6 makes the parentheses 0? That will be a positive 6. And what number minus 1 makes the second parenthesis equal to 0? That will be a positive 1. But hold on, you're not done yet. You need to go back, guys, and check these solutions to see if they make sense. How about you guys go ahead and check them and see which one doesn't work? One of these doesn't work, guys. So plug them back in. Plug the 6 in. See if it makes the problem true. Plug the 1 in and see if it makes the problem true. One of them doesn't work. Now, when you're working through My Math Lab, if one of the solutions work and one doesn't, you put in both solutions, the computer will mark it wrong. You only include the solution that makes the problem true. That's it. Okay, guys, so which one doesn't work? Type it into the chat box for me. Which one doesn't work? One of them doesn't make the problem true. Which one? Right, the 1 doesn't work, guys. Thank you, guys. So you would reject the 1, and so the solution for this problem would just be 6. So be careful on the assignments, be careful on the test, guys. All right, so that's it for the radical equations, guys. I am going to move on to the next part of this. And the next part of this has to do with the equations with rational exponents. Now, this one right here is not going to be tested. However, you will see problems like this on the assignments, okay? Equations with rational meaning fractions, guys, okay? Rational exponents. So what in the world am I talking about? Here's what I'm talking about. X to the 3 over 2 is equal to 8, or perhaps x to the 2/3 is equal to 4. By the way, guys, these fractional exponents, these rational exponents, they come from the radicals. The denominator represents the, here, let me use a different color, the index, and the numerator represents the exponent. So if I were to convert this to a radical equation, it would be the square root of, that's the denominator, x to the 3rd, the 3rd is the numerator, equals to 8. Likewise, if I were to do it on the one on the right, it would be the cube root of x to the second. The cube root is the denominator of the fraction, and the exponent, of course, is the numerator of the fraction. And so that's what this is. Now, how do you solve these? Well, it just so happened we just finished solving radical equations, so we can easily solve these. So guys, we square both sides here, and we get x cubed is equal to 64. Now you want to take the cube root of both sides to get rid of the third power, do the inverse. So you get x is equal to 4. Now over here on the right side, you want to get rid of the cube root. So you want to raise both sides to the third power. So this would leave you with x squared is equal to 64. And then you would take the square root of both sides. Now guys, here's the catch. Whenever you take the square root of both sides, you always get a compound solution, as in x will equal to plus or minus 8. So guys, what just happened? One of these equations produced a single solution, while the other one produced a compound solution. So the question is, how do we know which one of these rational equations, equations with rational exponents, will produce a single solution or a compound solution? Well, the bottom line is this, guys. You have to look at the numerator of the fractions. So if you have an equation in the form of x to the m over n is equal to c, you will end up with a single solution. You will get a single solution if m, the numerator, is odd. However, you will get a compound solution, as in double solution, if m is even. So this is the bottom line. So if your m is odd, single solution. If your m is even, you get a compound solution. So guys, I am going to do, actually, you know what? Let me go through the steps on how to solve this one. So first step, you want to isolate the exponential term. And then once you have that isolated, you want to raise both sides. Okay, this might require a calculator, guys, to the inverse reciprocal to the inverse of the exponent, and then you want to go ahead and solve. I am going to do a couple of examples with you guys. And remember, these are not on the test, they are simply on the assignments, guys. You can do the assignments as many times as you want to, whether it's a quiz or a homework, you can do them as many times as you want to. Now guys, as always, if you have a question, drop it in the chat box, please. All right, guys, so here comes the examples. Example number 1. So on this one, I have x minus 4 to the 3 halves power equals to 27. I'm gonna use a different color. So on this one right here, I want to go ahead and eliminate that exponent of 3 over 2. So I'm gonna raise both sides to the inverse of 3 over 2, which is 2/3. This is where the calculator is going to come in handy, guys. You wanna grab a calculator. All right, and on your calculator, you're going to take 27 and raise it to the 2/3 power. By the way, the exponential term, the powers, it's the delta or the caret. On some calculators, you might have y to the x or x to the y, something like that, okay? So it just depends on your calculator. Sometimes you might even have a square raised to another square, so something like that, okay? So type it into your calculator, guys, to get the answer. Now, if you don't have a calculator nearby, how do you simplify this? Remember, guys, the denominator is the root, okay? So you're taking the 3rd root of 27, and the numerator is the power, so you're going to square whatever this answer is. Cube root of 27 is 9, Shazam, that's 3. Okay, that's 3. And then you square it, you get 9. See, my brain is moving too fast. Guys, I forgot to ask you, is this one going to produce a single solution or compound solution? You guys tell me in the chat box, single solution or compound solution? Anybody? Single solution or compound solution? Okay, yes, ma'am. Compound solution. All right. So guys, compound solution. Do we agree? Look at the numerator. The numerator is 3. Okay, it's an odd number. If m is odd, you actually end up with a single solution. So this one is going to produce one solution, guys. So for this one right here, obviously the powers cancel out, leaving you with 9 because 27 to the 2/3 power is 9. And then you go ahead and solve it. Add 4 to both sides to get x equals to 13. And there you are. That's the answer, guys. We're going to do another one. Any questions? All right, so here comes the next one. Guys, drop your questions in the chat box. The next one is x plus 5 to the 2/3 power. So the first question I'm going to ask you is this one going to produce a single solution or a compound solution? Is it going to be a single solution or will it be a compound solution? What do you guys think? Drop it in the chat box, guys. Compound or single? Come on, guys. Compound. Okay, I got it. I got it. Very good, guys. Yes, it is going to be a compound solution. Why? Because the numerator is 2. So you're going to end up with 2 solutions. So for this one right here, guys, we're going to raise both sides to the inverse of that fractional exponent. So in this case, we're raising both sides to the 3/2 power, which cancels out the power over here. So we get x plus 5. And then on the right side, if you take 4, you raise it to the 3/2 power. You're just simplifying this, guys. The denominator is 2, so which means you take the square root of 4, and the numerator says 2, raise it to the 3rd power. So 2 cubed would give you 8. So this is going to turn out to be plus or minus 8. Now, it's up to you what you choose to do from here. Personally, I'm just going to work it out as a compound solution by moving the 5 over. So this will become x equals to -5 plus or minus 8. So essentially, guys, we have 2 equations here. One of them is x equals to -5 plus 8, which gives you 3. And then the other one is going to be x equals to -5 minus 8, which gives you a -13. So there are 2 solutions to this one. Any questions, guys? Any questions? Nothing? All right, everybody. We're moving right along. I think I have one more type to discuss with you guys. And okay, we're good on time. Remember, guys, the rational exponent ones, they're not on the test. However, oh, you're confused on these? Okay. We'll do some additional examples after I'm done with the recording, okay? So just hang on to that question. Put a star next to it so you can remind me. I got mixed up the last time with attendance. Okay, I'm gonna get attendance for you guys in a minute. Let me finish up. I'm almost done, guys, okay? So I've got one more type of equation to look over, and then I will go ahead and grab the attendance. All right, so here's the last type we're looking at today. And guys, that is the absolute value equations. Now, for the absolute value equations, guys, we're looking at any equation, guys, in the form of the absolute value of x equals to 4. You know what? Let me back up a little bit. Let me try and say this first. When we talk about the absolute value, guys, we're looking at the distance. We're calculating distance of a number from 0 on the number line, a distance from 0 on the number line. Distance is always positive except for 0. Distance is always positive except for 0. So which means, guys, whenever you take the absolute value of a number, it's always going to be positive except 0. Besides 0, distance is always positive. So if I were to give you a little problem like this, the absolute value of x is equal to 4, this is simply asking you what numbers have a distance of 4 units from 0 on the number line. There are 2 numbers that would have a distance of 4 units from 0 on the number line. Positive 4 or negative 4. Now, why is that? Because if you take the absolute value of 4, you get 4. And if you take the absolute value of negative 4, you also get 4. Remember, distance is always positive. Distance is always positive. So after class tonight, if you were to get in your car on your street and drive backwards while looking at your speedometer, guys, okay? The speedometer, even though you're moving backwards, it would record a positive distance, not a negative distance. So distance is always positive, whether you're dealing with positive value or negative value. Absolute value will always be positive except 0. So guys, listen, when it comes to solving the absolute values, here are some steps for you. And yes, you will see absolute values on the test, okay? So pay careful attention, guys. Number 1, you want to isolate the absolute value. That means that you need to get it by itself. Isolate the absolute value. Once you have the absolute value isolated, remember, guys, if you have the absolute value of x is equal to c, then this means that you're going to end up with 2 solutions. Either x will equal to a positive c or x is equal to a negative c. Now, if you want to summarize this into the step, you could say create 2 equations. Create a compound equation, same thing. Create 2 equations. And then step 3, you want to go ahead and solve your equations. And then it doesn't hurt, guys, to check. Some of these, you need to be careful with them. Check the solutions. Why do we need to check the solutions? Because some of them just don't work out, guys. Now, I am going to look at a couple of exceptions with you. There's a couple of exceptions here. So here they are. The first one involves the absolute value equaling to 0. When the absolute value is equal to 0, guys, remember there's only one number, okay, that has an absolute value of 0 from 0 on the number line. That would be 0. So essentially, this question right here is going to produce 1 solution, not 2 solutions, just 1 solution. What number would make this equation equal out to 0? And there's your 1 solution, negative 1. So that's the first exception. The second exception, guys, has to do with the absolute value equaling to a negative number. Guys, remember we just mentioned that. I just mentioned it to you. Whenever you take the absolute value of a number, it's going to produce a positive result. So therefore, you cannot take the absolute value of a number and get a negative answer. That is absolutely impossible. So guys, if that is the case and you notice that, you just say no solution. This particular problem will have no solution. But let's say you can't notice that and you try to solve the problem. So you do x plus 1 equals to negative 4 or x plus 1 is equal to positive 4 and you try to solve it. Look at what happens, guys, when you subtract 1 from both sides. You get x equals to negative 5. Now, if you take this negative 5 right here and plug it in and add 1 to it, let me just do it over here, guys. I'm going to just do it over here. Negative 5 plus 1, absolute value. Negative 5 plus 1 is negative 4. Guys, what's the absolute value of negative 4 again? Positive 4. Is positive 4 equal to negative 4? I don't think so. So that doesn't work. And if you do it with the other one, x plus 1 equals to 4, that would give you 3. 3 plus 1 is 4, but is 4 equal to negative 4? Absolutely not. So these are the two exceptions you need to pay careful attention to. When the absolute value is equal to 0, you're going to end up with one solution. However, if the absolute value is equal to a negative number, you're going to end up with no solution because that is impossible, guys. So guys, here are some of the type of questions you might encounter while going through the assignments as well as the test. This next one right here is very similar to one of the ones you're going to see on the test. And so guys, here is question number 3. This is not an exception. We are actually doing a problem. This one is similar to one of the ones you're going to see on the test. And then on Monday, well, actually, hold up a second. I just realized something. Monday is a holiday, Shazam. Okay, that's gonna be a problem. Guys, I think I might have to do inequalities with you. Ooh, because I just realized I won't have class on Monday. Okay, guys, so let's look. I am going to subtract 6 from both sides to try and isolate the absolute value. So this cancels out, leaving me with 12. Now that 2, this 2 here in front of the absolute value, many students like to distribute the 2. But guys, the best thing to do is to eliminate the 2 by dividing both sides by the 2. And so what I'm doing here essentially is reducing the problem. It's better to work with a simplified problem, okay? So rather than distributing the 2, it's best to divide both sides by 2 and get rid of it. Now, once you get here, you need to break this up into 2 equations. Once you isolate the absolute value, break it up, guys, into 2 equations. 4 minus 5 over 2x equals to 6, or 4 minus 5 over 2x is equal to a negative 6. All right, everybody. So now you got to go about solving these 2 equations to find the solution to the absolute value equation. Ask me questions, guys, anything. All right, so let's go ahead and work them out. I'm erasing at the top so I can have room to work out the problems, guys. Okay, so, all right, Jonathan has a question. Okay, Jonathan, wouldn't the 5 over 2x be positive? No, Jonathan. The only thing you change with the absolute values is the 6. Oops, I just erased that. Okay. What you're changing then, Jonathan, is the 6, the negative 6. You're changing the 6 to a negative 6. That's it. You don't change anything inside the absolute value. Now, you may be asking why are we just changing that? Because remember, Jonathan, this is the problem we started with. The question is this: what number, okay, when we take its absolute value would give us a positive 4? So positive 4 would give us positive 4. Negative 4 would give us a positive 4. So those 2 numbers, that's what you look at, not what's inside the absolute value, okay? The numbers that would produce the 4. So likewise, on this problem, what numbers when you take their absolute value will give you 6? What numbers when you take their absolute value will give you 6? That would be a positive 6, negative 6. That's why we're using the positive 6, the negative 6. We do not change the sign on the negative 5 over 2, never. And by the way, Jonathan, if you were to go ahead and change the sign on the 5 over 2, okay, listen, you check your solution and see if it makes sense. Personally, I would go ahead and experiment with that. As a math student, you should always experiment with these new thoughts you're having. Okay, well, wait a minute. If I were to go ahead and do it this way, would I end up with the same solution? Okay, so experiment, Jonathan. All right, guys. So now let's go ahead and solve the 2 equations. Oops, I still didn't erase that. I'm erasing this on the side, okay? I don't want you guys to get all confused here. All right, guys. So now, here's the first equation. 4 minus 5 over 2x equals to 6. I'm going to subtract 4 from both sides So this cancels out. I'm left with negative 5 over 2x is equal to 2. Now, guys, we can do this problem in one step, but just to avoid the confusion, I'm going to do it in 2 steps. If you're going to do it in 2 steps, all you would do is multiply both sides by the reciprocal of negative 5 over 2. However, students prefer to do it in 2 steps. So I'm just going to go ahead and start by eliminating the fraction first by multiplying both sides by 2. Well, actually, no, let me just do it here. Okay, like that, okay? So what ends up happening? The 2's cancel out, leaving me with negative 5x is equal to 4. And then I'm going to divide both sides by negative 5. So this simplifies to x equals to negative 4/5. So this is one of the solutions, negative 4/5. Now I'm going to do the other equation, guys. So for the other equation, I've got 4 minus 5 over 2x is equal to a negative 6. I'm going to subtract 4 from both sides. So I get negative 5 over 2x is equal to a negative 10. Now, some of you who are curious about how do you go around doing this in one step, here's how you do it. Take the reciprocal of the negative 5 over 2, which gives you negative 2/5, and multiply both sides by negative 2/5, guys. And it works, okay? So this cancels out over here, leaving you with x. And then on the right side, 5 goes into 10 2 times. 2 times 2 is 4. Notice I'm saying positive 4 because it's a negative times a negative, so I get a positive. So guys, here are my 2 solutions. And yes, you will see one like this on the test, guys. So if you were to see it on the test, would you be able to do it? If you're not able to do it, then you need to be asking a question or 2. All right, guys. So this is what I'm going to do right now. I'm going to pause this video